All right, so when I was growing up at about age 10, my mother lost her hearing in a single ear. So she was deaf, but only in one ear, and it made going to events really fun because I always forgot which ear she was deaf in. So I'd be sitting next to my mother, and I'd want to whisper something, and I'd be like, "Hey, Mom, did you hear the guy?" And she'd turn her head all the way around and go, "What?" Like all the way around, right? And then other times I would think I was on her deaf side, and so I would say something really loud, and she'd be like, "Wow, I heard you. Geez, you're right next to me," right? So it made things really fun. And over time, I started to learn that one of the reasons why I always got confused as to which side I thought she was deaf on was because she would sometimes act like she was deaf on the wrong side. But it wasn't intentional, right? It was almost like she got into the habit of not feeling comfortable of what she heard. So she would ask "what" as a way to clarify that she's gathering the right information. So sometimes she would say "what," and I would think, oh, she didn't hear me. And other times she actually heard me perfectly, but she just wants to verify that she actually received what she thought she received, right? So what this led to essentially was a situation where sometimes I would tell her something, and she would say "what?" And I would say, "Forget about it," right? And so I wouldn't say anything. That message never got delivered to my mother, right? And then at other times, I would tell her something. She would say "what?" And then I would say it again, but she actually did hear me. So the second time I'm telling her, she got that message twice, right? So I think you're picking up kind of what I'm saying here is this is a real life scenario where it was impossible for me to deliver a message to my mother exactly once, right? Okay, so now let's assume that we had better technology than raw communication, and instead we had carrier pigeons, right? Carrier pigeons, what a great technology, right? They can carry messages across the world. Can you believe that? Can you believe talking to someone in another continent in less than a month? Like, that's crazy, right? Crazy technology, carrier pigeons, really, okay? So let's say that I want to go to war, and I have, another army in another continent, and we're communicating over carrier pigeon, and I want to make sure that they attack at the same time as me, okay? This is important, because if we attack at different times, we could lose the war. Super bad stuff, right? You need to be very synchronized in your attacks when you attack another country, okay? I'll just tell you that from experience. Just trust me, okay? So here's my friend Novell. I'm trying to carrier pigeon him and make sure that we attack at the same time. So I'm like, hey, we're gonna attack at dawn, right? And everyone knows that Apple does not support iMessage over carrier pigeon. So he replies, right? And I get this whole green bubble, unfortunately. But he replies, right? So, and now I know that he saw my message. And that's important because if I didn't see his reply, then I had no confidence that he saw my message. And the goal here, right, is to synchronize when we attack. So if I don't know for a fact that he saw my message, I'm not going to attack because it's too risky for me. The problem is he's now in the same boat where he doesn't know for sure that I'm going to attack because he doesn't know whether or not I got his reply. So naturally, the only thing to do is tell him, great, okay, I saw your message here, right? But I now need to be sure that he got this message, so he has to reply to it, and then I have to reply to it, and then kind of eventually we get to this point, we've replied so many times, and now you're sitting here thinking, okay, but you both know that you're attacking at dawn. Well, yes, as humans, we kind of know, right? But if you were to put this in an algorithm, ironically, it's actually mathematically impossible to solve, okay? And here's kind of what I mean, is I've responded this many times, and as humans, we have instincts, and we know at some point in time, like, okay, he's obviously seen my message, and I've obviously seen his, and we've gone back and forth enough times we just know. But computers don't know. They have to have a finite number to determine this. So let's say the finite number is 10. We've gone back and forth 10 times. We know that we're confident that both people know. Well, unfortunately, now you're kind of all the way back to square one, right? Because this is now the 10th message. And now you need to make sure that your 10th message got delivered. And you need to make sure that they saw it. And they need to make sure that you saw it, right? So like you're doing this all over again. It's literally impossible to send a message exactly once and guarantee that the other side got it. Mathematically impossible. So instead, what we can do is we can guarantee two other types of systems. We can guarantee that our message is only delivered once or not at all, right? Or we can guarantee that it's delivered at least once. It could be delivered once, could be delivered 5 times, could be delivered 1,000 times, right? If I had carrier pigeons, I could take 1,000 carrier pigeons and launch them all in the air and be sure that at least one got there. But if all 1,000 of them got there, great. Except now you have 1,000 pigeons, and I don't know what you would do with all that poop. So let's say that we take that back to our carrier pigeon concept, and we attack at dawn. And let's say in this case, the message fails. Well, if we were at most once delivery, we only deliver once, then that's it. Our message didn't go, we drop it, we forget about it, we move on. This is HTTP, by the way. If your message does not get delivered, it just gets dropped. Browser doesn't care. You can try writing retries and all that, but that's it. You don't care. Or I could say, I'm going to retry, and I'm going to send it over and over and over and over until I finally get a response. Okay? Now, there might be some in the audience that are really confused about this slide. I did a poll earlier and realized there's a generational gap with this green bubble, so I made another one for you people. Okay. Okay, so basically, I'm just sending the message over and over and over again till time ends forever to guarantee that my message goes through, and I'm waiting until I get a reply. But we don't actually know which side dropped the message, right? On the other side, it could look like this. It could be that actually every single one of my messages went through, and they replied to every single one. But for some reason, I just wasn't getting the replies. But you'll notice there's no passive aggression here. There's no like, I already got your message, Joe, right? Like, no, there's none of that. It's just, okay, I got that message. I'm going to reply again. As if it's the first time I'm seeing it, I'm just going to keep going and keep going, okay? So now let's get back into the actual world of computers, which is why you're here. You're probably sick of carrier pigeon technology already. So anyways, real life scenario, background processing. Let's take YouTube, for example. When you upload a YouTube video, the very first thing it says is rendering, right? And then you sit and watch that rendering bubble for maybe hours, who knows. It takes forever. Well, if your message hit the server, and then the very server that your message is on sat and spun that process, then that server would basically be unavailable for further messages. It would crash, essentially. And at high load, at high scale, such as YouTube, this is what you would call a very bad architecture. So instead, what you do is you take a system called message gateway or a message bus or broker or whatever word you want to use here. And you kind of put this man in the middle. That's the message brokers in the middle. And your web server is the producer sending the messages. And then you have a server that's the consumer receiving the messages, right? So it looks like this. You send a request to your server. It then sends that message to the message broker. And then the message broker sends a message to the server that actually renders the videos. And that way your server that handles web requests can continue to handle web requests, and then you can scale the video renderers differently, okay? So the problem here is what happens if your message does not get sent, right? If we're at most once delivery, then you have to handle that. What do you do if a message gets dropped? What do you do if that processing doesn't know that it needs to process anything because the message broker never delivered the message? Or on the other side, what do you do if you get 2 of them, okay? So here's an important distinction. If you try to throw in a message broker and you try to do this and you try to say, hey, Nick at Utah.js told me that I can never have exactly once delivery, but I'm getting exactly once delivery on every single message, I'm going to say, haha, wait till you scale. Okay? This is fine 99.9% of the time. But once you get to a certain point, you will have duplicated messages or dropped messages at some point. Okay? So if you want to handle it, you need to decide, do you want dropped packets or do you want duplicated packets? Okay? But let's just take for a second and imagine that our message broker was perfect. We had this magic wand and we could somehow define the laws of mathematics and say we have exactly once delivery, okay? I hope that exists. Kafka claims that exists. It doesn't exist, okay? But let's say you have the magic wand. Now, here's the problem. I can guarantee that message gets delivered to the server exactly once. But what happens if my server crashes? Okay, what happens if you run out of memory? What happens if your network dies? What happens if you run out of power? What happens if there's an earthquake? Right? Like it goes on and on and on. Servers crash for so many reasons, usually because it's your code, right? But it could crash. And now what? Now you have the exact same problem. You can decide, am I going to retry and start over? Or am I just gonna forget about it and let it slide? And so you'll kind of notice here, this is turtles all the way down. Doesn't matter how good our message system is. It's irrelevant. Because you still have to handle the fact that you might have duplicates or dropped things, right? So what do? So let's talk about background processing, okay? Back to the YouTube example that we had. Let's say you're doing something in the background. You've offloaded your jobs onto a job server or something like that. What do? Well, usually, in these scenarios, you want at least once delivery, meaning you are okay to do the job over and over and over and over as long as you are guaranteed to actually do it at least once, right? Now, the problem is sometimes that means you're rendering a video 20 times, 30 times, potentially for one video. But it does mean that your code has to handle the fact that it might be ran more than once for the same task, right? Imagine if that task was something like creating a user and for some reason you didn't check for IDs and you just went and created that same user over and over again and now you have lots of the same user in your system. Like there can be lots of problems, right? If you're not aware that you're getting your things multiple times, you can create problems. Likewise, if you pick the other one and you say, okay, we'll do it most once delivery, so I never do duplicates. Okay, but now you might not actually do the processing you say you're going to do, right? I can't give you an answer. There's no magic answer. You have to think about this for every single feature you build because it's not always the same. The easy answer is probably do at least once and handle duplicates. That'll get you for most situations, but not all of them. If you try to reset your password and it resets your password after you just reset your password, that would be very frustrating as a user, right? So there are cases where maybe you want at most once delivery. And then you have event streams. If you're doing distributed systems and you want to tell other services or microservices or whatever that something happened and allow them to do something, then now you have these messages that can get lost or duplicated. And again, now you have to ask yourself the same question. Am I going to handle this as a duplicate and do work over and over and over for a repeated message? Or am I just going to let it drop? Some people implement event streams as caching mechanisms. I will tell the other services the data I have so that they can update their data store so that the response is faster. And maybe every 12 hours they go and sync the cache or something. And if that's the case, then at most once delivery is just great because you know that you have that backup where you will eventually catch up anyway. But in other cases, you might want at least once delivery because you need to guarantee that you do something for every single message, right? WebSockets by nature are at most once delivery. They will only deliver a message once. And if you don't have retries baked in or any of that stuff, then you cannot guarantee that your end users are actually getting the messages you were sending to them. Now, in most cases that I've seen for WebSockets, it's usually notifications and stuff where if the end user doesn't get it, it's okay. So at most once delivery is probably correct. But if you need at least once delivery, you need to do other stuff, right? You need to add some type of duplication or error checking stuff into your WebSockets. So basically the point is, forget about how reliable your message system is because you have to handle duplicates anyway or lost packets anyway. How are you going to handle that? What is this use case that you're building for determine is the right one for this job? It's either at least once or at most once. Those are your only two options. Okay, so what about the actual thing sending the message? We've been talking about the receiver, right, this whole time. So our original analogy, we have a server sending a message to the message broker. But what about that? Because messages could still get lost there while you're trying to send it to the message broker. So here's a really quick code snippet. I can't promise this code works. I wrote it this morning. But let's say that you get a request for users and you're adding those users and you have a database transaction. And in that database transaction, you're sending this message to your message queue, right? And you're doing it in a transaction. Everything seems fine. Well, there's two problems with this. The first problem is you now have a runtime dependency on your message broker. So if your message broker goes down, every single request will now fail. If you're okay with that, great. The other problem with this is transactions don't always succeed, even if they've made it all the way through your business logic. They can fail on a commit. They can absolutely fail on a commit. And if they fail on a commit, what just happened is you now sent a message for something that didn't actually happen, okay? You have this penguin that's totally out of place, right? You're the consumer that receives this message will look at it and say, hey, you said you created a user, and I went to go get it, and it wasn't there, right? Because you didn't actually do it. Your transaction failed. The database rolled everything back, but the message still went through. So I know some of you are sitting there, and you're like, okay, wise guy, why don't you put it outside the transaction? So yeah, we send the message outside the transaction. That'll get them every time. All right, so the problem here, of course, is what happens if sending the message fails? Okay, your transaction is now succeeded. You now successfully created a user, but you didn't send the message, right? So if you're doing it most once delivery, maybe this is okay. Maybe you're okay with this, right? So maybe that's fine. But if you're doing it at least once delivery, this is not okay because you cannot guarantee you sent the message. In fact, this is such an interesting problem that the only way I've ever seen to actually deal with it is to not have your code directly interact with the message queue. And instead you use a pattern called the transactional outbox. So what the transactional outbox is instead of you writing directly to the message broker, you introduce yet another piece in your infrastructure. I know you're all hating me right now, right? You all have a monolith, and now you have 5 pieces, and you're like, what just happened? Okay, so you now have a web server, and now instead of publishing a message to your message broker, you're just putting it in a database. And then you're going to have another piece, the relay, that takes it out of your database and puts it on the message broker, right? The reason for this is it guarantees transactional integrity with the thing you're actually doing. So this is the same code as earlier, except the difference is instead of putting it on the message queue, we're just putting it in the database. We have a table specifically for messages, and all we do is insert into that table, inserts only. And then we have another piece of code, the relay, that reads that table and publishes it to the message broker, okay? And that's pretty much it. That's how you do the transactional outbox. And again, as a reminder, you have exactly 2 message guarantee types. You can either deliver a message at least once or at most once. Those are your only 2 guarantees. The only 2. And use a message broker. They help you a lot. Helps you not have to reinvent so much network architecture code. And use an outbox. Those are kind of the key takeaways for this when you're doing distributed systems and message passing. Thank you. Now, conveniently, were there questions?
I have a question. The service that reads the database, is that just pulling the database, or how does it work?
Yeah, so it does kind of depend on your database technology, but typically it's just polling. If you're using Postgres or something, you can also do subscribe notify. But yeah, you can just poll every, I don't know, half second or something, and then publish, yeah.